Good morning. I am Manuel Zarzo from the Department of Applied Statistics of Universitat Politécnica de Valencia. And here in this unit, I'm going to talk about descriptive statistics. So there are different videos in this unit of descriptive statistics. And here in this video, we will talk about some general concepts. So the first important concept is the concept of population. Population is defined as the set of objects that we are interested in, for which we intend to get conclusions. The issue is that usually the population is rather large. For example, if we are in a company that manufactures pen drives, we will say that the population is the set of all pen drives that are going to be manufactured by the company. So we talk about objects or also called individuals. The reason is that statistics as a science was developed from states, from governments that wanted to get information from the people living in the countries. So is that usually individuals refer to persons, to people, but now in statistics is a concept more general. So we say that we have information from individuals or from objects, but the concept of individual can be anything. So a sample is a subset formed by part of the objects of the population. For example, we can take a sample, a set of 20 pen drives that are produced in this company. So here in this picture, we're showing that usually the population is very big, very large, so that usually we don't have the information from all the individuals. So what we do is to get a sample. This process of taking a sample is called sampling. So by sampling, we get a sample, we get by random a subset of the individuals of this population, and then by analyzing the information from this sample, we want to get conclusions from the total population. So there's a process of statistical reasoning that is called inference that will be part of another unit of statistics. An important idea is that the sample must be representative of the total population. And the rule, the only method to guarantee this representativity is to carry out a random sampling. Okay, so the object of sampling is to get information from the population by analyzing the sample. Okay, and then we say or we give the name of statistical inference to this process of reasoning to obtain conclusions about the population by analyzing samples extracted from the population. For example, if I take a sample of people and I get the information that 5% of them had blue eyes, I will say that at the population, the percentage of people with blue eyes is 5% plus minus certain kind of error. This error depends on the sample size mainly. So, examples of populations. We can ask different things, and the first idea is, does the population exist? Usually we can say yes. For example, if we have a general election in Spain, okay, we can think about the population of people who vote, okay, and then we can make a survey to study the intention of voting of Spanish people in a general election. So the population exists, so all people who can vote exist, and we can have a list of all of them. Okay, it is millions of people, but we know exactly the information from all of them. Or if we want to study the development of certain pathology in buildings in Valencia, also again, this is a long list of buildings, but we can have a complete list with all of these buildings. But surprisingly, sometimes the elements of the populations just exist partially. What does it mean? For example, if I talk about the number of laptop batteries sold every day at a computer store, I can have for every day the number of batteries that are sold, but I can have the information until a given day. But every new day will correspond to a new individual of the population. It means that we know the information at present and then past observations, but on the future, every day we will generate new individuals from those populations. So the these future individuals are considered as also part of this population. Or, for example, the number of mistakes or errors that we can find in the invoices issued by a company. Again, we can have the set of all invoices up to today, but in the future, new invoices will be generated. So these future invoices, we are also part of the population, and this is why we say that the individuals just exist partially. But surprisingly, even more surprisingly, sometimes the population does not exist. For example, if I create chemically a new polymer and I want to study the resistance, as the polymer does not exist yet, I cannot check the resistance, and then I don't have the values. So this is a population, but it does not exist yet. Okay? Or, for example, I have a die. I want to investigate if the die is correct or not. It means if the die is symmetric. So I want to check if the probability to get the numbers from 1 to 6 is the same or not. So the way to check this is obviously to throw many times this die and to check the frequency of the values. So the individuals of these populations will be every value that I get when I throw the die. But until I carry out this experiment, I don't have the individuals of this population. Okay? So in general, in any experiment of laboratory, until I carry out the experiment, I don't have the individuals of this population. Well, another important idea is that the size of populations usually is large, but not always. For example, if I talk about the population of countries in the European Union, is the size large or not? Okay, I say population of countries. I don't talk about population of people. Obviously, the population of people is many millions living in the European Union. But in this case, my population is only for the countries. In this case, the number of countries in the European Union is not large. It is just 27. So it is an example of a population which is small. Okay, so another idea is that the output of any process always presents some type of variability. So in general, we can say that we have some kind of input, we have a process, and then the process generates an output, and then I can measure something. And so if I use an instrument of measurement with enough accuracy, I can have data which are not always constant. And then we say that all real populations always present variability. It means that it is not possible to have two identical objects, two identical individuals. Usually it depends on the accuracy of the instrument. For example, if I talk about the height of people, in a group of people, everyone has a different height, so it is an example. Okay? So we define as random variable any characteristic which can be expressed numerically that fluctuates among the individuals of the population. Okay? So we are in statistics. The statistics is the science that wants to extract useful information from individuals. So imagine a class of students, and I ask the age of the students, and all my students say that they are 18 years old. Okay, so the information from this variable is obvious. All values are 18, so I don't have to apply any kind of method to extract the information because the information is trivial. Okay, all values are 18. This is why we say a random variable. Variable means that it varies, that the value or the magnitude fluctuates. It's not always constant. Okay, like the height of people, the weight of a person, so on. There are many examples of variables. Okay, this was the case that I was explaining. If all my students are 18 years old, no statistics is required to summarize the information. Okay, so now let's talk about the different types of random variables. According to the nature, I can talk about qualitative or quantitative variables. Okay, qualitative, for example, the color of something, the brand of a product, the sex of a person with two possibilities, men or women. But also we can talk about quantitative variables. For for example, physical magnitude that we measure, like the weight or the height or electric intensity or whatever. Okay, so in another type of things, we can discuss the number of characteristics, and then we can talk about one-dimensional random variable, two-dimensional variables, or in general k-dimensional variables. What does it mean? Okay, so imagine that I have two columns of data, two columns of values. So there are two possibilities. It can be two one-dimensional variables, or it can be one two-dimensional variable. Okay, so I will talk about this later. Then, according to this set of values, we can talk about discrete variables or continuous variables. Continuous means that values are expressed with decimals, which is quite often, okay, like time. Time can be expressed in minutes, seconds, milliseconds, and so on. I can give the value with decimals. So discrete means that the value does not contain decimals, and usually is the result of counting. Okay, the values are like 1, 2, 3, but never with decimals. And then there is an interesting question that I want to discuss. So imagine that I ask the height of a person. Okay, I have a class of students and I ask all of them to indicate their height. Usually the height, if it is indicated in centimeters, when I look at the values, probably I will see that they don't have decimals. And so the question is that a discrete or a continuous variable? Well, it is continuous because I can express the values with decimals. Okay, usually in this case, the problem is that the values are rounded. Well, so here we finish this first part of general concepts about descriptive statistics, and in the next video we will continue. Thank you for your attention.